Okay, this is going to go with our notes that are 4.1b, and really we're going to work on graphing the polynomials and talking about end behavior. So remember, in order for it to be a polynomial, you need whole number exponents and real coefficients. The degree is the largest exponent, and then you can name it based off of that exponent. Like if the largest, it's a degree of 3, it'd be called a cubic. And then the leading coefficient is the number in front of the first term, or it's the one with the number in front of the one with the highest exponent. So that's just a little bit of review. And we're going to just jump right in and start talking about end behavior. And end behavior, basically what that means is what's happening on the ends of the function. So as the function continues, what happens? So this f of x equals x is a linear function. It has a positive slope, so just a quick sketch. It should maybe go through the origin, but I'll try to make it as close as I can. So this is a line. It's one that matches it. And now what end behavior is, what's happening as you go to the right on the x-axis. Notice how the function is going up on the y-axis. So like you have 3, 3, then you have 9, 9. So as you're going to the right on the x-axis, you're going up on the y-axis. Well, that's as x continues to get bigger, x is going to approach infinity. So this means x approaches infinity. As x continues to approach infinity, the function, the y values, will continue to rise. So as you go to the right, the function is going up, or as you go to infinity on the x, the function is also going to infinity. Versus here on this side, as x gets smaller and smaller, so negative 10, negative 20, negative 30, the function, the line, is continuing to go down, and it will continue in this fashion forever. So as x approaches what we say is negative infinity, it's kind of the concept of going negatively in the left direction, the function itself will approach negative infinity as well. It's going to continue to decrease on the left side here. So basically, as you go to the right, the function goes up. As you go to the left, the function is going down. So as x approaches infinity, the function also approaches infinity. As x approaches negative infinity, the function also approaches negative infinity. Okay, over here, it's the same thing except for instead of a positive x, it's a negative x. So that makes it a negative sloping line. So now, as your x's are going to positive infinity here, your function is going down. So, and it's going to continue to decrease on this right side here. The function is going to continue to go down to negative infinity. So we say that as x approaches infinity, the function is approaching negative infinity. Just keeps going lower there. But on this side, as x is approaching negative infinity on the left here, so to the left of the origin, the function is going up. So as you go to the left, your function is going up. So as you go to the left, you're going up, which is as you go to the negative infinity on the x, the function is going to positive infinity. So that was a linear expression. Let's look at some quadratic expressions. Remember from the last unit, a quadratic expression is shaped like a parabola. So just a quick sketch. This is what this might look like. And so with parabolas, since it's positive, it opens up. So as you're going to the right on the x-axis, or as x is approaching infinity, your function is also approaching infinity on the y. So it's continuing to go up here to infinity. And the same works on this side. If the function is approaching negative infinity on the left, or as you approach negative infinity on the x, your function is also approaching infinity. So for a quadratic equation, again, as x approaches infinity, the function approaches infinity. As it approaches negative infinity on the x, your function is approaching infinity. Basically, they're both going up. Versus now if it's a negative x squared, that changes the parabola and it opens down instead of up. So that might look like that. And again, this is just a rough sketch. But as you go to positive infinity on the right here, as x approaches infinity, so as you go more and more to the right, the function is going to keep going down further and further. So it's going to approach negative infinity. So as x goes to the right, the parabola goes down. Same over here, as you're approaching from the left, so you keep going to the left on the number line. As your x's are approaching negative infinity, your parabola is going to keep going down. It's going to also approach negative infinity. So for this one, it's down and down. So if it opens up, or if it opens down, that's how that's different for those. Okay, how about an x cubed? So we haven't graphed these yet, but x cubed, I always remember the positive x cubed looks like I'm drawing kind of like an S. I draw an S, but it's like this. So it's the same kind of pen stroke motion, S cubic. So that's how I remember it. So this is what the cubic one looks like. So for cubic, as x approaches infinity over here, the function is also approaching infinity. So as you're going to the right, you're going up as well. So as you approach infinity on the x, you're approaching infinity on the y. Now as you approach negative infinity on the left, your function is also approaching negative infinity. So those kind of match up here. It's right and up and then left and down. So this is going to be a similar idea, except for, so if this is the positive x cubed, the negative one looks like this. So positive and then negative. You kind of switch it around. And that switches our end behavior as well, because if we go to positive infinity, our function is actually approaching negative infinity. As we go to negative infinity on the left, our function is approaching positive infinity. So to positive, it goes to negative infinity, and negative infinity, it goes to positive infinity. Now, if you recall or look back on your notes, the end behavior for these is the same as the end behavior of the function of x and the function of negative x. And these two have something in common. They're both odd functions. And we call them odd because they both have odd degrees. This is a degree of 1 and this is a degree of 3. So actually odd functions all have the same end behavior, whether they're positive or negative. Leading coefficients. Now you'll see x to the fourth. Now this is an even exponent, so these are called even functions. And so since all odd functions behave the same way at the ends, even functions actually behave the same way at the ends as well. So an even x to the fourth, a positive, so your leading coefficient is positive here, a is bigger than 0, it's a positive x to the fourth. It's going to have the same end behavior as our parabolas. It might look a little different. Since it's x to the fourth, that means it's going to have like 3 turns. So sometimes it looks like this. But as you go to the right, to positive infinity, your function goes up. As you go to negative infinity to the left, the function goes up. So it behaves the same way as those parabolas. When you had a positive x squared, the end behavior was the same. Similarly, when you have a negative x squared, or x to the fourth, when you had a negative x squared, it's a parabola that goes down. The negative x fourth will behave the same way, just looks a little different. It has 3 turns instead of 1 turn in the x to the fourth, but they're both going to approach negative infinity here. Negative infinity and negative infinity as you go to the right or as you go to the left. So all even functions that begin with or have the exponent that's even number behave in the same way. So here are some rules, and now that I've thought about this a little bit more, I think that it's a little bit confusing the way that this is written here, but maybe instead we could just make a little cheat sheet. Let's say that the degree is even, so that would be like x squared, x to the fourth, x to the sixth. Let's say it's even and your a is 0, or greater than 0, I mean. So that's like positive x squared, positive x to the fourth, positive x to the sixth. All of these are going to have something in common. The sketch will look similar to this. Now they're not all going to be parabolas, but this is just a sketch of what it might look like. So for all evens, as the x approaches infinity, so as you go to the right, the function goes up. So as x approaches infinity, that's supposed to be an arrow there. As x approaches infinity, the function also approaches infinity. Then as you go to the left, so as x approaches negative infinity, the function also approaches positive infinity. It goes up. So as you go to the right, it goes up. As you go to the left, it goes up. So it got a little confusing there. Now let's say it's an even function. Again, except for that this time your a is less than 0. So that would be like negative x squared, negative x to the fourth, negative x to the sixth. So the sketch of this is going to be something that looks like this. They're not all going to be perfect parabolas. They could have some turns in the middle, but they will all have the same end behavior, which means that it'll be facing down in the end. So for even functions that have a negative leading coefficient, it'll always be as you go to the right, so to positive infinity, the function goes to negative infinity. And as you go to the left, so to negative infinity, the function goes to negative infinity as well. So it's going to negative infinity both from the left and the right. Now let's say you have an odd function. If you have an odd function and your a is greater than 0, that would be like x cubed, x to the fifth, x to the seventh. They're not all going to look this way. The x to the first is that line with the positive slope. But I always draw my sketch like this, and I make that S-type figure. So that would be my x cubed. They're all going to follow that same general pattern, so that's just a sketch. Which means if it's odd and you have a positive leading coefficient, as you go to the right of the x-axis, the function approaches positive infinity. It goes up. And as you go to the left on the x-axis, so negative infinity, the function goes down. So those kind of match up. As you go to the right, it goes up. As you go to the left, it goes down. So that's how that looks. Now, the last one would be if you have an odd function and your a is less than 0, so that'd be like negative x cubed, or negative x to the seventh, fifth. The sketch of this will be similar to the odd with a positive, except for it's reversed. So you start at the top and go down. So this one then is as you go to the right, the function goes down, so it approaches negative infinity. As you go to the left, or negative infinity on the x, the function, f of x, goes to positive infinity. So this is a really great table to maybe write out and just have as a guide until you have this down. So pause it here if you need to take some more notes. So just describing the end behavior. Anytime I ask you to describe end behavior, this is what I'm looking for. And you'll have to write this out. It won't be fill in the blank necessarily. So you first look for your highest degree. So that would be this term right here. So it's an odd degree of 3. It's odd, and it's a negative coefficient. So the sketch of it will look like this because it's an odd degree and negative leading coefficient. So as you go to the right, you'll go to negative infinity. As you go to the left, you're going to positive infinity. Here, this one is the highest degree is x to the 5th, and it's a positive leading coefficient. So it's an odd function again, but this time it's positive, so that one looks more like this. This is just the sketch. It's just used to help us out. So as you go to the right, your function goes up. So as you go to positive infinity, it goes to positive infinity as well. As you go to the left, the function goes down. So it goes to negative infinity. Here, the highest degree is x to the 4th, and it's a negative coefficient. So that's going to look like this. This is my sketch. It's even and negative. So it goes both the same way and it opens down. So they're both, from the left and from the right, they're both approaching negative infinity. D, the highest coefficient is x squared, or the exponent I mean, and the coefficient is positive. So this is a parabola that opens up. So from the right, it's approaching, going to positive infinity, and from the left, it's also approaching positive infinity. Okay, I think that's, oh, we got to graph one, or maybe two, but this is end behavior graphing it. Okay, so graphing it, what I want to do is decide what it's going to look like. So this one is an odd degree, and a positive leading coefficient. So it's going to look like this, odd and positive. So as x approaches infinity, my function should also approach infinity. And as x approaches negative infinity, my function will also approach negative infinity. So over here it's going to go up, and over here it should go down. Now to decide what happens in the middle, I'm going to make a table of values, and I'm going to choose -2 to 2, and I'm going to pick these 5 points for x every time. And then I'm going to evaluate the function for each of those. So f of -2, I'm going to plug in -2 in for my x and solve for my y. I'm going to get -8, and 4 plus 8, so that's 0, plus 2 plus 3, I'm going to get 5. And I'm going to keep doing that. So I'm going to find f of -1, and I'm going to get 5 again. If I get f of 0, you will get 3. If I plug in 1, I'm going to get 1 cubed is 1, plus 2 is 3, minus 1 is 2, plus 3, I'm going to get 5 again. And when I plug in 2, I did this one earlier, I think I get 17. So then I'm going to graph that. And so it's going to be a little hard to graph this, but 2, 5, -1, 5, 0, 3, doing the best I can with the iPad here, 1, 5, and 2, 17 will be way up here. So remember that it was supposed to go down over here and up over here. So it's going to look like this in the end. So I can connect these dots from left to right. So this is what I have so far, and it's going to continue to keep going up because I know my end behavior goes to positive infinity. And then what does it do here? Well, I know it's got to come back down because it goes to negative infinity. So here, I don't need any more points. I can just predict that it's going to go this way. And that gives me a nice sketch of my graph. It's not perfect, but it's a good sketch. Okay, that's all the time I got for you. I do have one more example, so check the class notes for that last example, but hopefully